All right, guys, we're moving on to 10.6b, circumference and arc length. Again, I can find the circumference of a circle and use it to determine arc length. So yesterday we talked just generally speaking about circles, about some of the features of circles like the diameter and the radius. And so let's just kind of start there, and we'll start talking about circumference a little bit. This is really a fascinating subject. But here you have a circle, sort of. Okay, I got a little bit off there, but it's okay. You can kind of get the general idea. And let's say this is circle C. It has point C right in the middle, the center. And let's say we have point A over here and point B over here. And so if we go straight across from A to B through C, we understand that this is the diameter of the circle. Okay. And let's just say, for example, that this is a 1 inch diameter, okay? A 1 inch diameter circle. I can tell you that if we were to measure the circumference of this circle, in other words, if we were to start right here at point B and we were to go around the circle, I'm going to try my best to keep my same line. Wow, that's pretty good. All the way back to point B again. If we were to go all the way around that circle, I can tell you that this length right here would be 3.14, and it would just keep going. Now, I want you just to think about that for just 1 second and think about what that really is. And so if we were to take the circumference of the circle, which is 3.14, okay, the circumference of the circle, and we were to divide that by the diameter of the circle, which is 1, and we could say 0.00. If I take 3.14 divided by 1, what do I get? I actually still get 3.14. And if you remember anything about mathematics, you will remember that this number is pretty special. It's actually an irrational number that keeps going on forever, and it is known as the number or the letter pi, okay? So there is an interesting relationship here that happens between the circumference and the diameter of a circle. Again, circumference is the distance around the circle. So the distance around the circle is always 3.14 times bigger than what the diameter of that circle is. So watch this. So the circumference divided by the diameter always ends up equaling pi, okay? And that may not seem like a very dynamic thing right now, but let's just think about this for a second, that we could actually use this to help us to find the circumference of a circle. So in other words, if I was needing to isolate this C right here by itself, how would I do that? Well, now I'm dividing by D, which means in order to get this by itself, I need to multiply by D. And watch what happens when I do that. I have to do it to both sides. And what I get is circumference equals pi times diameter. Ladies and gentlemen, this is our formula now that we have just developed for how to find the circumference of a circle. The circumference of a circle is nothing more than pi times the diameter. Now, we could expand on that definition just a little bit because we understand that the diameter equals twice the radius, right? 2 times the radius. The radius is half of the diameter. So if we take the radius, I'm sorry, I put 2 pi. If we take the radius and we multiply it times 2, then it will give us the diameter. So in other words, another way to write this is circumference equals 2 pi r, okay? 2 times r times pi. So again, these are two different ways that we can state the circumference of a circle. And this is also very useful to help you if you needed to figure out what the diameter of a circle is. You can actually take circumference and you can take pi, and you can help try to figure that out as well. Okay, so let's look at an example here. We'll actually look at a couple examples here real quick of how this is useful. And so let's say we have a circle. We'll call this example 1. And let's see, we have a center, comes out to here. And let's say that that is 3 feet, okay? And now we need to find the circumference of that circle. Well, I could use either definition. I could think about the fact that, well, if I went ahead and extended this out and made it a radius or a diameter, I've already been given the radius, if I want to make this a diameter, I know that this whole diameter would actually be 6 feet, okay? I could do it that way and then use this formula right here. So circumference equals pi times diameter. Well, my diameter just happens to be 6. So that means this would have to be 6 pi, okay? And you can just leave your answer stated in pi. That's fine. I could also think about the fact, well, I was already given the radius, and I just happen to have a formula that tells me what to do when I'm given radius. So circumference equals 2 pi r. And remember, I already know that 2 pi is part of my formula, and my radius happens to be 3. Well, again, multiplication is commutative, so I can take 3 times 2, which is 6, and this still just becomes 6 pi. So you can see how that the circumference of this particular circle would be, in fact, 6 pi, okay? Same exact thing is true, and it's even easier if I'm given the diameter. So, for example, I've got another circle. Sorry, I drew that one quick, but you get the idea that this whole thing is 9 feet. So if that whole circle is 9 feet, I know that is my diameter. My diameter across is 9 foot. So circumference equals pi times diameter, or very simply, it's just 9 pi. Pretty doggone easy. It's easy as pie, pardon the pun. All right, so now we need to move on to maybe something a little bit more complex, and that is finding arc length, okay? Finding arc length. So let's take, for example, another circle here, and we'll call this number 3, and we'll maybe only do one of these. But let's say we're given a circle here, and let's do this. Let's call this S. We'll call this T, and we'll call the center here R. So that is, in fact, a diameter that goes across. And we'll put V out here. Okay? And we are told, for example, that this angle in here is 30 degrees. But what we are asked to do is find the length of arc VT, okay? We're told to find the length of arc VT. What is the length of that arc? So we're looking for this length right here, okay? Now, I'm not being asked for the angle measure, but the angle measure may, in fact, come into play, okay? So let's just think about this for just a minute. ST is a diameter. Remember, a diameter splits a circle into 2 equal parts, or it is a semicircle. And so in a semicircle, it has to equal 180 degrees. Well, you will note that I'm already given that this one here is 30 degrees, okay? So if a semicircle is 180 degrees, and I've already been given 30 degrees, then that means the part that's left inside of here has to be 150 degrees. So this would have to be 150 degrees right here. And you notice I'm looking for this arc length right here. How in the world could I find that arc length? Well, remember here, we're kind of talking about a radius, right? From R to V or V to R, that is actually a radius. So to find the arc length, to find VT, we are going to take angle VT, okay? And we're going to divide it by 360 degrees. Remember, there's 360 degrees in a total circle, but we don't need the total circle. All we need is just this 150 degree portion, okay? So what we're going to do is make that a fraction, because we need a fractional part of this circle, not the whole circle, okay? So we would have to take the angle of VT, the central angle, divided by 360, and we're going to multiply that times our formula for the circumference of a circle using radius, which is 2 pi r, okay? So now watch what happens. Again, we're looking for arc VT. So we know that angle VT is 150 degrees. So I'm going to take 150 divided by 360, and I'm going to multiply that times 2 pi r, okay? So if I do that math, if I take 150 divided by 360, let's see if we can get that as a fraction. And this is when a good calculator really does help you out. So 150 divided by 360 comes out to 5/12, okay? So let's just keep our work going down. We've got 5/12 times 2 pi r. Remember, I could also just go ahead and write that as a fraction as well. So I can make anything a fraction, just put it over 1. And now I can just multiply straight across. So if you notice here, I have 2 times 5, which is 10 pi. Now what is my radius here? My radius, I didn't really include this in here, but I needed to, is 5 centimeters, okay? So my radius is 5 centimeters. And then on the bottom, I have 12, okay? Let's finish this out. 10 times 5 is 50 pi over 12. But again, what number will go into both of those numbers? Well, we know that they're both even numbers, so I could actually simplify this 50 down to 25, and 12 divided by 2 would be 6. So my final answer here would be 25 pi over 6. Again, all I'm doing here is I'm taking whatever my central angle is, dividing it by 360, and then multiplying it by the formula that I already have for circumference, okay? Because I'm not trying to find the whole circumference. I'm trying to just find the arc length part of that circumference, all right? So hopefully that's been helpful. Again, if you need help, especially with this second part, just make sure that you get with us, and we will be glad to help you with those individual problems that you're going to have concerning that, okay? Thanks.